No, I will be off. I'll put myself off.
Then can you? Yeah, but mute yourself.
You be here at least.
Yeah.
Okay, you go in the next room.
Yeah, because I'll be hearing everything twice.
Close the door. Close the door and be here so that if I need anything, I can call you. इस बच्चों के बिना तो क्या करें? Oh, Jai Sri Ram! Welcome everybody. Welcome to Bharat Marg. Okay, see we are here with Mr. Ved Kaila. Ved Kaila ji, Jai Sri Ram. Welcome, welcome, welcome. Welcome to Bharat Marg. Friends, today we are going to talk about Ved Kaila ji is going to teach about uh, the functions, introduction to the functions in mathematics. He is an IITian and also very accomplished in many fields, and of course in teaching. Okay, and he has been teaching in Peel region, what we call in Canada. Okay, so he is going to cover a lot of things, folks. You just make sure that you take notes, ask any questions. You will be given homework, and also see here. This is our WhatsApp number here. I am just going to give you, okay, so that you can contact us. You can send a message and register here. Okay, you can register here by sending a WhatsApp. But anyway, let's talk about introduction to functions today, and a lot of things are going to be covered. And we want to thank Mr. Ved Kaila ji for coming into Bharat Marg and teaching the children. Friends, I can say you, he has a heart for teaching, and he wants to do this service. Okay, so take advantage of the maximum. But before going further, friends, please make sure to like the video, comment on the video, share the video with as many people as you can, friends. Okay, because that's when we can reach out to many families. We want to help the children, and that's a goal of Mr. Ved Kaila ji also. So share, and also, friends, make sure to support us by all means by sharing the video, and also by contributing and providing donations to us, so that we can go ahead and do much more things. Okay, please. And this is our WhatsApp number, and we send out one dharmic message every day, and we are involved in not only in free tuitions, but also in a lot of other good causes. So support us by sending donations as well as by sharing the video. Okay, and here is Mr. Ved Kaila ji. Ved Kaila ji, आपके लिए बहुत बहुत स्वागत.
धन्यवाद जी.
Hare Krishna, Hare Krishna.
My name is Ved Kaila, and I am here to present introduction to functions. I hope you can see the slideshow. So this is a course during summer 2024, courtesy Bharat Marg. Here is the course summary. This is targeted to students 18 plus years of age, grade 9 to 12. That will be useful to many other. It may be called by other names. All you need to know before you start this course is some elementary arithmetic, algebra, and a little bit of geometry. We do this course online in English and Hindi during August to October 24, by having 2 classes each of 1 hour per week. The schedule is given here, and that is the schedule as of now. At the end of this class, you will be given some time to ask questions, which you can probably also write, and we will try to answer as much as possible. So in this course, you are going to learn what is a function, how you define it, the terminology or the language that is used for this specific purpose, different ways in which you can specify functions, how to plot functions, find their characteristics, do them one after another, which is called chaining, make modifications, which is called transformations, and also solve simple real life problems. Now, this course is not intended to be very rigorous, but meant to create interest and curiosity in simple mathematical functions. You will learn how to use graphing tools and reporting tools and use certain apps to make your life easy. We will keep it simple and we will limit our scope to single variable functions. As regards methodology, we will be using stories and examples to make points clear instead of detailed definitions which can perplex students. Focus will be on fundamentals, so though the details may be omitted, at the end you will be able to comfortably explore and learn many things on your own or in the school class. At the end of the course, we plan to have a test which will be acting as a certification point. So, what all do we learn in this course? We will learn the basic characteristics of functions. Now, these words might appear very perplexing to you, but I can assure you by the end of today's session, you will have a fair idea of what is domain, what is range, what is meant by maxima, minima, end behavior, asymptotes, zeros, intercepts, etc. And the kind of functions we will learn in this course can be classified as linear functions, quadratic functions, exponential and logarithmic functions, series functions, reciprocal function, square root function, absolute value function, etc. For each of these, you will learn how to evaluate the value of a function, interpret a given relation, tabulate, plot, or graph a relation. Note that I am using the word function sometimes and relation some other time. They are quite interrelated but not exactly the same. We'll be shortly explaining the difference. In short, a function is just a well-defined relationship between two or more entities. Entities mean some data. It may be numbers, it may be some other type of data like day of the month or the name of the month or the name of a country or things like that. So in general, we call such data as entities. So a function is just defining or describing the connection between two or more entities. And as I said, for simplicity, in this course, we limit ourselves to relationships between just two entities. When there are more than two entities, things get pretty complex. And to start with, we begin with functions involving just two entities. Now, some of what I have said so far might be going over the head. So, best way to go forward is to first look at certain examples of functions. So here I have listed certain examples. Price of a given kind of pizza depends on its size. So here there are two entities. One is price and one is size. So if you tell me the size of pizza you want, I can tell you the price. Because I perform the function of telling you the price. So you can say I'm using a function tell price which tells the price for a given size of pizza. Example 2, the interest earned on a given principal amount deposited for a given duration depends upon the rate of interest. Higher the interest rate, more interest you earn. So there is some kind of formula which is used by a function to tell the amount of interest when you give the rate of interest to that formula or function. Next example, area of a square depends on the length of its sides. So if you tell me the side length of a square, I can tell you the area of that square. Because I am using a function, I can perform that work or a function, and therefore this person or this app or this formula is essentially or can be called just function for simplicity. Next example, average maximum daytime temperature in Toronto depends on the month. So if you tell me the month like January, I will tell you average daytime maximum temperature is -5. But if you tell me the month as August, the average maximum daytime temperature may be 30 degrees centigrade. Next, the height of a very young child depends upon its age. So if you tell me what is the approximate height of a child who is 1 year old, I can say approximately 1.5 feet or 45 centimeter. Next example, price of a movie ticket would be a function of, or which means depends upon the day of the week. So if you say what is the price of a movie ticket on Monday, it may be $10. On Tuesday it may be $10. On Wednesday it may be $10. Thursday may be $10. But Friday may be $15 because there is more demand on Friday. Saturday may be even more, $15, $16, and Sunday might be less, maybe $9. So price of a movie ticket depends upon the day of the week, and mathematically speaking, we say that the price of a movie ticket is a function of day of the week. Here, the first entity with which you are asking the question, which we normally described as x value, is any day out of a set of days, Monday, Tuesday, up to Sunday. Whereas the output value of the function or the answer given is called a y value. Now, this x and y is just a convention, input being x and output being y. Next example, you often need to convert temperature from Fahrenheit to centigrade. In United States, they talk in terms of Fahrenheit. In many other countries like Canada, they talk in terms of centigrade. So, if you were to convert a centigrade into Fahrenheit, you would be using this formula written as capital F, which is equal to a function which depends upon the centigrade value, which can be calculated by multiplying the centigrade value by 9, dividing it by 5, and to that result by adding 32. So if you were to put centigrade value as 100 in this formula, 100 divided by 5 will be 20, and 20 times 9 will be 180, and if you add 32, you will get 212. So if you tell me centigrade 100, I will tell you 212 Fahrenheit because I am using this formula. If I give this formula to a monkey or to an app, I can just give it any centigrade value and get the Fahrenheit value. I don't need to remember what is the logic being used by that monkey or by that app or formula. It is like having a cook. You tell the cook the name of the dish and the cook presents you the dish. You don't need to know how to make the dish because the function of making the dish is best performed by the cook. Similarly, here the function of converting a centigrade value into Fahrenheit is done by this function. Ideally, we should call it as a centigrade to Fahrenheit converting person or a centigrade to a Fahrenheit converting app. But mathematicians are lazy, they just call it a function. On the other hand, if you were to convert a value of temperature in Fahrenheit and want it in centigrade, you will be doing just the reverse, which is written here. You will take the Fahrenheit value, subtract 32, and then whatever you get, multiply that by 5, divide that by 9, you will get the value in centigrade. So this function, which converts Fahrenheit into centigrade, uses this formula to do the job or to do the function. And as you might have seen by now, I am using a small letter f to denote function in short. You can write it anything, but the convention followed is to use a small case letter f and avoid writing this whole long sentence of the formula to convert a centigrade into Fahrenheit is like this. Instead of writing this long sentence, we just use the small case letter F. So with these examples, you get an idea as to what is meant by a function. Next, we talk of function terminology or vocabulary. So whenever you have to ask a question, you give some input, like we give the day of the week to get the value of the movie ticket. So this day of the week is given as input. We normally denote it by a letter capital X. And this is called an independent variable, because nobody is telling what question to ask. We don't question the person who is asking question, why you are asking this question. So it is an independent variable. The person asking the question can ask any question. He is independent. So we call this capital X or an independent variable, and this is used to create an input or a question which is to be put or asked from the person performing the function. On the other hand, the answer depends upon the input. So when you say movie ticket on Sunday is $9, that 9 depends upon Sunday, and therefore it is called dependent variable. And this one is denoted usually by a letter capital Y. So many times mathematicians will not say independent variable or input, they will just say X. And everybody in their community knows what is X. Whenever somebody says X means there is something to ask a question. Similarly, when somebody just tells Y, you understand that this is the answer that you got from the function, or the answer you got from the person performing the job when he was given an input of X. So do not get confused between input, independent variable, and X. They are all the same. Similarly, dependent variable or output or Y is just, they are all the same. So usually we will be short and we will be calling in terms of X and Y. Okay, the next part of vocabulary is domain. And these are some of the words which overwhelm the students, because the textbooks and class, they don't spend much time explaining this, and the students are bewildered. So what is domain? Domain is, in short, a set or a range of valid values that input X can possibly take. For example, in case of the movie ticket example, if the function is asked, what is the value, what is the price of a movie ticket on Tuesday, you can answer it. But if the question is asked in such a way, or the question asked is, what is the price of a movie ticket on a green day? Well, the green does not appear in the range of days that we understand. It is neither Monday, nor Tuesday, nor Wednesday. This is an unknown kind of thing which I don't understand. So we say that the input is not in the domain, or the input is not valid, not recognizable. Similarly, if somebody were to ask you what is the square root of 9, you can say 3. The function works very well. You ask what is the square root of 25, you can say 5. But if the question asked is what is the square root of -4, well, a negative number is not valid as far as a square root function is concerned. The guy who is supposed to find square root doesn't know or does not recognize any negative numbers. So we say that -4, or for that matter any negative number, is not in the domain of the square root function. So I hope I have made the point clear. A domain is just a range or a set of valid values which can be accepted as input. Similarly, range is a set of valid values that output y can possibly have. So if you were to ask a person what is your age, and the guy answers -25, so then the only thing you can say is that you are crazy, you are mad, you don't know what you're talking about. So instead of using this abusive language, we say that y is out of range or output is invalid. So instead of using invalid, we say output is out of range. Therefore, to make things work smoothly, we put restrictions on domain and range. By restrictions, we mean that if somebody asks a question with a wrong x value, we can ignore it. We do not accept any question with input data which is not in the domain. Typical examples being the age or the quantity of something you buy cannot be negative. So we can put certain restrictions mathematically. How to put these restrictions, how to write these restrictions in short, we will learn in the next classes. Now we have used the word variable. Input or question can be variable, output or answer can be variable. But what kind of variable? So as you have seen, you can ask the price of a movie ticket on a day of the week. So that will be like Monday, Tuesday, Wednesday. You can ask the price of a number of apples, like 1 apple, 2 apple, 3 apple. These are called discrete values. So you can buy 1 apple or 2 apples, but you cannot buy 1.5 apples. So they are in steps. They are fixed quantities, nothing in between them. They are not continuous. Such data is called discrete. We need to get familiar with this terminology so that when we get something wrong, we can use just one word to explain what is wrong instead of writing a sentence. Therefore, we need to be comfortable with such vocabulary and terminology. There are also other kind of data like real numbers. So for example, if you buy potatoes, you can buy 4 pounds of potato or 1.3 kilograms of potato. So these can be real numbers, and real means which can have a fraction or a decimal as part of it. So variables can be discrete numbers or set of values. There may be integers like 1, 2, 3. There may be real numbers like 1.5, 2 by 3, or things like that. So both x and y can have values like negative numbers, 0, positive numbers, real numbers, and all that. And all these can be restricted. So I have given some other examples here which we can go through. This should make sense. The collections of fixed data are called sets. So you can have a set of days, you can have a set of months, you can have a set of grades. And using these keywords or terminology, we can make our points clear in a very few words. Next, let's understand what is a function and what is a relation. A relation in general refers to some kind of logical connection between two entities. But a function is a kind of relationship which is more definite and unambiguous. There is no doubt about what is a function. For example, a boy can have 3 girlfriends, but a husband can have only one wife. So the relationship of marriage between a boy and a girl is definite. It's a function. A girl having 2 boyfriends or a boy having 2 girlfriends is a kind of relation where you cannot tell. You can certainly ask who is the husband of this lady, and you will get a definite answer. But you might not get a definite answer when you ask who is the boyfriend of this girl. So the relationship is a loose connection between two sets of entities, whereas a function is a definite relationship between two entities. So a function can be a relation, but a relation need not be a function. Now, this is good as a story, but how do you determine when something is a function and something is not a function? So to explain that, we go to the next slide where we have a set of pairs. So in this question 1a, when the x value is -5, y value is 1. When the x value is -3, the y value is 2. When the x value is -1, the y value is 3. When the x value is 1, y value is 2. So definitely we can tell, given the x value, we can tell what is the y value. Whereas in the question B, which is another way of telling similar story, the oval on the left is the x and the oval on the right is the y. You can see when the x value is -1, you can say for sure that the y value is -3. But on the left, when the x value is 1, you cannot be sure what is the y value. Is it -3 or is it 0? So B is a relation but not a function, because some of the values in B are such that you cannot tell for sure what is the value of y for a given value of x. Similarly in C, you can see that when x value is 0, the y can be 4, but at the end, when x is 0, the y value is 1. So that is confusing. So that is not a function but only a relation. In the next D, for every given value of x on the left, there is a definite value of x, definite value of y on the right, which means it is a function. Now the data that is given to you of x and y need not be a table like in the previous slide, it could be a graph. How do you tell whether it is a function or it is not a function? Now at this stage it may be a little confusing to you, but this x and y in each of these graphs denoting relationship between x and y, there is a simple way to find what is the relationship. So here I have given a demonstration, so let's see whether it works. Are you able to see this slide? So you can see when I draw a vertical line and go from left to right, it cuts the blue graph at one point only, so that is a function, but it cuts the red graph at 2 points, and therefore the red graph is not a function. Okay, so I think we lost connection. Okay, so in this slide we talk about parent, child functions. Functions which are very basic are called parent functions, and the functions which are created by using the parent function and modifying them are called child functions. Once you understand parent functions, it becomes easy to understand child functions. And using parent functions and their transformations, you can simulate complex and composite functions. There are various ways to explain or specify the functions, and they are listed here. Statements, tables, graphs, pictures, equations. So what does the function statement look like? So a grocery shop may display a notice like this, which is not a convenient way of doing things. Or it might put a table like this, which also is not convenient because if something changes, you need to make a lot of changes in this notice. Or you might use a graph or use an equation. We have seen examples of graphs, we have seen examples of equation. Equation we saw for Fahrenheit and centigrade. For the graph, you can click on this example and you see what is the meaning of a function description through graph. So let us see. If you can see this graph, there are 5 points here. Each of these points have an x value. One has got an x value of 1, the second has an x value of 2, 3, 4, and 5. They also have a y value. The first one has a y value of 1.5, the second has a y value of 3, fourth has a value of 4.5. To find the y value, go horizontally on the left. To find the x value, you go vertically on the up and down. On this graph, you can see that I have written x on the horizontal axis and y on the vertical axis to make it clear what data I am talking about. In the next class, we will talk about how such graphs can be made and interpreted, but you can explore on your own using desmos.com and by creating a free account over there. So that is all that we had for today. Any questions, please feel free to ask. Any questions?
Jai Sri Ram.
Jai Shri Ram.
Yeah, so happy to be here, डॉक्टर वेद जी. वेद जी, आपके लिए बहुत बहुत धन्यवाद. आपने आके इधर सिखाए. You taught the children for the thing, and any question we will ask you also, comment also, and let you know also. And thank you guys. You know what, Ved ji is going to do a class on Sunday too. Okay, we will send you the time. Make sure to register, folks. Make sure to register so that we can send you more specific information regarding the max class. This is our WhatsApp number. I am just putting it here. just do a free, it's a free registration. Okay, you register so that we can give you more information, more updates on the homeworks and whatnot and all. So you just register. Here is our WhatsApp number. How to register? Simple. Just send us a WhatsApp, and we will get you registered with your name, where you are from, what language you do, and send us the message. Okay, so that we can get it done for you. Okay, looking forward to talk to you. Thank you, Vedji.
Thank you.
Appreciate it, and friends, we will see you in the next video. Till then, Jai Sri Ram, Jai Jai Sri Ram.
Jai Shri Ram.